Hi everyone, welcome back to my channel Testing Mini Bytes. I am your friend Abudan Shaktivel, and in this video, we are going to see about how we can do scrolling in Appium. Scrolling is obviously not so straightforward in Selenium. So in Selenium, we have JavaScript script executor where we can pass few method arguments like scroll into view or scroll up, scroll down, and then it automatically scrolls it for us. But in case of Appium, it is not so easy, right? Because we have a lot of moving parts here. In this video, I'll try to break down what are the problems and how we can resolve them, right? So let me first switch to the IntelliJ. So in the previous video, we have navigated to the view screen, which is obviously this. After clicking on views, we get the view screen. Now we need to scroll to the web view, and then we need to click on it, and that's our task, right? So now I have created a method called scroll for mobile, and then I pass the by locator here, right? So this method looks very simple with 2 to 3 lines of code, but basically it does a lot of things. Like it calls a lot of methods internally. We have this element not enabled, this not enough page, perform scroll, and then you have perform scroll, finding whether you are doing it on Android or you are doing it on iOS. So it basically has a lot of method calls internally, right? But it just works, right? So don't worry, I will explain them into very simple words. These are all very easy to understand as well. So let's see the first complication. Okay, if I take any device, and then if I go to inspector, let me quit the session and then create a new one. So let me click on views, and let me try to inspect it now, right? So, but this time when I inspect it, I'll give the accessibility ID as web view. Okay, so this web view is actually present at the bottom and currently not visible. Okay, when I try to search this now, it obviously shows 0 elements. Okay, when Appium inspector shows 0, when you try to use it in the code, it will throw you element not found exception. Pretty clear, right? Now, if I scroll down, and then now if I try to find the same accessibility ID, it returns you the element, which means in Appium code, it will find the element and you can operate normally. So you have to obviously do the scroll. And one thing that you need to understand is, by default, when you try to find the element, it will say it cannot find the element and throw the element not found exception. But the same behavior, if the same app is built in iOS, this is an Android app, right? If it is built in iOS, when you try to inspect this app, it will show one element. Okay, it will show one element like this. Okay, but when you try to click on tab or something, it will not do it because the element is not visible. Okay, so in iOS, the tricky thing is, even though it is not visible to your naked eyes, if it is present in the page, even in the scrollable views, then it will say, I can find it. But when you try to operate on it, it cannot do any operation like clicking or set keys. It cannot do anything. So that's the difference between Android and iOS. Okay, so this is the first pain point. So I have problem here. Difference in the way how Android and iOS locating strategies work. In Android, if an element is not present in view, it throws you an exception. It is pretty easy to handle here. But in iOS, if the element is not present in the view, it says I can find the element. But obviously, when you try to operate on it, the visible parameter will be false. So you cannot do any operations. Okay. And one more tricky thing that we need to understand is this visible parameter will not be even present in Android. So if you go here, there is a lot of parameters: text, class, package, check, enabled, all that. But there is no visible. Okay, so you cannot even use visible as a strategy to identify whether the element is coming to this scrolled or not. So we cannot use a same strategy in both Android and iOS. For Android, we have to find it differently. For iOS, we have to find it differently. That's the ultimate thing we can learn from it. Again, guys, if it is confusing, just remember one thing: the way how Appium works with Android is a little different. When you do find elements, in Android, if it is not in the view, it will say 0 elements and then it throw exception. But when you do driver.find elements, it returns you a list containing 0 elements. In iOS, when you try to find element which is not in the view, it will give you find elements with 1 element size. But when you do any operation on it, it throws error. Okay, so the visible parameter will be false. If it is in the view, then it will throw then it will have visible parameters as true. This is first one. Okay, so how we are going to solve this problem? That's when. So if you notice here, we forget about the page source. We will come to the page source next. Okay, first thing is we need to find whether the element is in view or not. Okay, that is the first criteria. So first I'm checking if the element is not enabled. If it is not enabled, then I want to go inside and then I want to perform the scroll. Okay, right? So first now I want to go to web view. Okay, first I want to check in the view whether it is visible. If it is visible, I will click on it. If it is not visible, I have to just scroll and then I have to search. So this is the whole operation here, right? So now I want to perform scroll, but this condition is what we are interested in. Let's go to this condition. So if I directly use driver.find element, it throws an error, right? So it says element not found exception. To avoid this, I'm using find elements method. So when you do driver.find elements, it turns you a list with 0 elements. Okay. So now if the Android is what I'm doing, so if the test is Android test, okay, then basically I'm returning elements.is empty. Okay. So which means if it is empty, okay, you cannot find the element, go ahead and perform the scroll. Very simple. For now, we can imagine these 2 lines are not there. Okay. So if it is not there, if the size is empty, you go ahead and perform the scroll and search again. Do this operation until you get the element size as 1. Okay. So then you can stop scrolling. When this becomes 1, it'll be false. And if it is false, it won't scroll. It will go back to the column. Very, very simple. Now this is solved. Now, how many times I will scroll like this? Okay, I don't know. Sometimes the page will have 3 scrolls. Sometimes it will have 4 scrolls. Sometimes even 10. I don't know how many times I have to scroll. So you cannot set a counter. I cannot set some counter like int count equal to 0 and stuff like that. Because the problem is if the element is found in this place, okay, or you have to it will still try to scroll 10 times before throwing an exception or try to operate on it. So we don't want to do that, right? So that's why we will use page source. Okay, so that is the second problem. The problem is we need to know when to stop the scrolling. When to stop the scrolling? When you find the elements. Sometimes if the element is not present, you still have to stop the scrolling when it reaches the end of the screen. Okay, there is no direct way in Appium that you can find, hey, whether I have reached the end of the screen. There is no direct way. So how we do that? That's when we use page source. So when I get the page source, it's almost like your Selenium. So when you get the page source, it gives you a DOM elements, right? So first I'm assuming it is an empty string. Okay, so the first time, obviously this will be always true. For the first iteration, this previous this comparison will be always true. Okay. Based on this, it'll either decide to scroll or not. Okay, once it goes inside, let's take a scenario. Now similarly, I want to scroll till list. Okay, so it is not there in the DOM. This is true. Now obviously the first time this is empty and this is also true because we will try to compare with the current page source. Okay, we will try to get the page source and compare it with empty string. Obviously it is different. So I am returning not, which means this will be true. So it goes ahead and then updates this value with the current screen value. Okay, update this value with the current screen value. Now this is the first screen value, that is before scroll. Okay, this is before scrolling. Okay, now this is a before, it will update this value. Now this is before scroll, and then it performs the scroll. Okay, let's assume it performs the scroll right. Now let's assume this is true. Here, if you come here, it will again check the value that we updated. Let's assume this is 1 2 3 4. It again checks after scrolling. It checks the new value. So let's assume that is 4, 5, 6, 7. Okay, then these two are different, then it again becomes true, and then it will again scroll. So basically, sorry, when these two will be different, so it will scroll again. Okay, so when you reach the end of the page, okay, when you reach the end of this page, both these page sources will be same. Okay, so that time it will return false. Okay, and then it will end this and then come out. So this is the two things that we need to keep in mind. So one, how to find whether the element is there or not, and then how we can find whether we have reached the end of the page and stop scrolling. Okay, we cannot keep scrolling, okay, when there is a failure. Okay, we just have to search till the end. Okay, and then stop scrolling. Okay, once this is done, we have to perform scroll. Okay, there is a small method called as perform scroll, and we come here. Let's assume there is a device. Okay, this is a device. Okay, when you try to get, so there are multiple devices in the market. So this is the third problem. Okay, there are multiple devices in the market. So there are multiple devices in the market with the different screen resolutions. Okay, so you have to even accommodate that. Okay, the problem is when you have a different screen size. Let's say there is a text box or something. Okay, if you do some text, okay, in this emulator, it covers almost half of the screen. Maybe if the screen size is even smaller, it will even cover more than the half. Okay, if it is a bigger size, then it will cover only 1/4 of the screen. So there are the way how these things work, varies accordingly. So we need to make sure that we perform the scroll from here to here. Okay, let me use annotation and then clearly explain what I'm saying. What I'm saying is we can. So basically, we want to scroll from here to here. Okay, so not from here to here. That also will be scrolled, but we are not sure whether the keyboard will be there or not. Or we can scroll from here to here, because in the top there may be some notifications and stuff like that. So we cannot even touch that. So the best place to scroll is this, right? Obviously, there can be even interruptions here as well, but most of the cases it will not be, right? So let's close this. So let me clear the drawings and then close it. So now, based on the screen resolutions, we have to do it. The first thing we have to do is find the size of the device. Okay, so that's what we are doing. So first, we are finding driver manager.get driver manage.window.get size will give me the size. Okay. Let's assume this is the device. Okay, so this get size will give me the x length. Okay, the x length and then the y length. Okay, let's assume the x length is 500 and then the this one is 1000. Okay, now we want to start the scroll from here. Okay, from almost here to here, maybe from the center of the screen, maybe from here to this point. Okay, maybe just 3/4. This is almost, let's say this is 1000. I want to scroll till 250, and then from I have to start from 500 and then end my scroll till 250. So this is how my scrolling should work. Okay, then what is the x-axis and y-axis? Okay, so the x-axis is basically starts from 0 and this ends at 500 here. Okay, so it should be x/2. So this is my start x, right? So that's what I'm saying. Int start x equal to get width by 2, which goes basically going to give me 250. Now I also want to find start y. Okay, let's come to start y. Start y. Also, I want to start from here. You can also start from here. You can also do that. But in my case, I'm going to do it for simplicity reasons. I'm dividing by 2. And my start y is also divided by 2, which means the coordinates is here 250, 500. Okay, so this is the coordinates I'm starting. Okay. And then it is going till this place, right? So the x is still the same coordinate. X is still, the end x will be still the same. But the y is, if this is 1000, okay, if this is 1000, as I told, I need to scroll till 250. Okay, so if it is 1000, if I have to make it 250, I have to just multiply it by 0.25. So that's what I'm doing here. Okay, or it's 1/4. Okay, and then I'm just converting to the integer. Okay, so you start from here and then you end it here. That's it. So I'll clear all the drawings now. Let's take an example. So once you find from where to start the scroll and where to end the scroll, you just need to call based on which device you have. You have to use the new Android touch action and iOS touch action. That's the only difference. Apart from that, everything remains the same. Again, you could also club this into one method and pass the new iOS touch action or new Android touch action from the caller method here. Okay, but for simplicity reasons, I'm not doing it here. Okay, that's actually basically using the Java concepts, right? Where we leverage inheritance and all that. So yeah, but here, so once we perform the touch action, first we need to press the start X and start Y. It's like almost you pressing on the device. Once you press on the device, wait for 2 seconds, and then you move your finger to the end point. So this will basically scroll from so this will basically scroll like this. It will start here, it will end here. Okay, it will end in the scroll here. So since I already there at the end, so it will do the scroll something like this. Once it does it, you release the finger and then you perform this action. I repeated the same thing here. So this is the whole idea behind how we can perform this scrolling. But just that in Android we do this, but in iOS, if it is iOS, then you cannot rely on isempty. As I told, it will still return you 1. Even if it is returns 1, you have to get the first element and get the attribute whether it is visible. If it is visible, then you break the flow. If it is not visible, you continue with again searching and scrolling for the element. So this is the whole idea behind scrolling. So once we implement all this, I simply added the method called as scroll for mobile and then pass the bilocator. Guys, that's what I told. If you don't use bilocators here, and then directly using page factory, then the logic to find the scrolling will be very difficult. You need to handle exception. I don't know how people are doing it, but it is pretty complex. So with by, you can easily do it. That's why I normally use by. It helps me in dynamic locators, avoids tail element, helps in operations like scrolling and all that. So always prefer using by. Okay, once it scrolls it and we will wait and click. Let's try to run and then check if it still works. So I have this ready. So if you notice, this starts to scroll. There are different ways how you can write the logic to scroll. In this case, I have used Android touch action. There is also sequence new implementation for this. But yeah, it still searches and it found the web view and it clicked on it. So now the test passed. Again, I normally don't create tests for passing. So let's assume I give some invalid value like this. Okay. Let's try to run it and then check what's happening. So always make sure that your test fails and it fails correctly. It should scroll till the bottom because the element will not be there. After going to the bottom, it should not try to scroll, okay, because it would have reached the end of the page, right? So we are testing the second behavior. Yeah, it reached the end of the page. Now it tried to just check once. When the page source matches, it stops scrolling. So that's perfect. Now, if it is find the element midway, okay, instead of going till the end, okay, let's try to see if it is also working. If I try to find some element called as list, let's do it. It should not try to scroll after that. Obviously, it won't, but just to make sure that we have written correct code. Okay, bride dials groom wedding. Okay. So it should scroll till list. It finds the list now. It clicks it. So it's perfectly working fine. Again, guys, you notice all these elements are having same properties. Okay, they all hold the same properties like I mentioned before, and we use dynamic locators like this. But again, this is complicated to remember the element name. So what I normally do is I create types. Okay, here also I have created some enums. Okay, for example, these are all the elements that are present in view screen. Okay, after clicking on views, we will see all these elements. Okay, so instead of passing them as text, you could also pass them as enums. What I can do is I go here and then I say view screen type dots, and then I want to scroll till web view, and then I go there to this class, and then I change this to view screen type, and then of this is element, and then I simply say elements dot get name, and then this should also work, right? So let's try to run it once again, and then say it is okay. So this way, like, you don't have to create multiple elements. Your code becomes very readable. See, it is very, very readable, right? People know. Again, you can also do static imports. So you want to click view screen element web view, yeah, or you can make it as click on view screen element web view. So it's more readable and easily understandable. So there is no chance you can make spelling mistake. So this is how effectively you can write code. So I had found the web view, clicked on it. So I see you guys in another great video. Until then, Tata, bye bye, see you guys, bye bye.